Today I'm gonna make a quick video on sample variance, and when it comes to your statistics, you do have to deal with a lot of your measures of spread, is what they call. So you have your measures of spread where you're dealing with your mean, your mode, your medians, and variance and standard deviation, things like that. So today we're gonna look at sample variance. So with your sample variance, okay, I'll first give you the population variance, and then I'll give you the sample variance, the formulas that you're going to be following or that will be used. So by hand, this would be the formulas that you are using. So for your population variance, okay, for your population variance, you have your formula that looks like this. All right, and my summation symbol look a little weird, but here you go. So here you have one of the population data points minus the population mean of mu squared all over big N. Now, this part right here is what you call your lower case sigma. All right, this is lowercase sigma squared. That is the symbol for your population variance. So anytime you say symbol like that, when it comes to statistics, that is the symbol that they use. So that is what you call lowercase sigma. Now, as we know with uppercase sigma, that is summation. Okay, this is summation. So you take your values, you add up all your values. Of course, you come up with a sum or some number after you add up all your numbers and all that. So that's what that is. So that's summation, but that is what you call uppercase sigma. Okay, uppercase sigma. Now here you have what we call deviations. So this is your deviation of your data point minus your sample mean, or in this case, population mean. All right, now the population mean, of course, is mu. This is the Greek letter or lowercase mu, okay? This is what this is, lowercase mu. All right, this is your population mean, okay? Your population mean, that's what that is. So when you're dealing with variances, and I'm explaining what variance is, just in case for those that really don't quite grasp what that what that word is. So when you're dealing with your variance, you have to have some sort of deviation between, well, actually you don't have to have it. Actually, there's naturally some deviations between the data point and the mean. So anytime you're calculating whatever mean that you have based off of data points that were either garnered or given to you, there's going to be some deviations there. So like I said, this is some sort of deviation. All right, so this is the deviation. So you may have data points either higher than the mean or lower than the mean. That's what happens when you're dealing with some kind of stats when they deal with your data points. Okay, so again, you're going to have a data point either higher than the mean or lower than the mean. Okay, so you have your deviations here. Okay, and last would be your size or population size. Okay, this is your population size. So that means the number of data points that are, well, present in that data set. All right, so with the population variance, again, with the variance will measure the spread around the mean. I'm going to say that one more time. The variance is the value that measures the spread around the mean. Now, when you calculate it, now one value really doesn't make much difference. But when you calculate two or more, then you start to see more of the deviations when you compare two or more data sets. And that's really what they're for. For the variance, you may have what you call ANOVA, which is called analysis of variance. Okay. Now, when you're using that with the analysis of variance, that means that you are comparing two or more variations. Now, there may be a case where you're dealing with a lot of these data sets where you are comparing the means. The means may be exactly the same or similar. That could happen. So how do you really compare, well, these data sets if their means are the same? Well, you go to their variances and you go to their standard deviations, which we'll get into in a second. But that's what you use that for, okay? So here is the population variance. You see your deviations. I know it looks a little messy, but we'll clean it up later on. But you have your deviations, lowercase mu for the mean, because that's what this is. This is population mean, okay? Population mean, lowercase sigma for your variance, and you have your population size, all right? Now, for your sample variance, which is basically the same formula, just a slight difference. So in this case, for the sample variance, we just use a lowercase s. That's all we use that for. You have your summation symbol, which is your uppercase sigma, okay? Data point minus the sample mean. You square those deviations and add them up in the end. And then you're going to divide it by that slight change, which is n minus 1. So this is your sample size. Okay? And I'll explain a little bit at the end why you have that n minus 1 as opposed to n. Okay? Now it does have something to do with degrees of freedom. Okay? So we'll look at that later on in the video. All right, so I'm actually going to show you how to do this by hand really quick. Then we're going to go into Excel, which is actually much, much better as far as anybody is concerned, or any program is concerned, or any form is concerned. All right, and we'll check it out. All right, so here you go. Again, same thing with the deviations. That does not change. You have your summation right here. Okay, and again, lowercase s squared. All right. And while we're dealing with your variances, before I go into the actual calculation, when you deal with your variances, okay, you deal with your variances to find standard deviation, okay, not sample, sorry. When you find standard deviation, all right, so your standard deviations, okay. So the standard deviations, you can kind of think of it as like the average of the deviations. You know, I mean, I know I'm kind of oversimplifying it, but that's really what they are. So to find your standard deviation, so let's say if you're looking for the sample standard deviation, and I'll give you that. So I'll just use SD for standard deviation. To find this, you just simply find the square root of s squared. Just like if you were dealing with your population standard deviation. So you have your population standard deviation, which is of course the same thing. You just basically find the square root of the variance and you have your standard deviation. So here is your population standard deviation. Okay, I'm going to show you by hand how to calculate these values. But in this case, we're going to use simply the sample variance. Okay, and I'm going to show you how to actually work this out, because normally when you're dealing with a lot of your calculations, usually you deal more with the samples as opposed to the whole population. Okay, so we're just going to use sample variance right here. Okay, so again, to kind of go into the calculation, kind of give you a visual view of what you're looking at. So when you're looking at variance, okay, really quick. All right, again, think of it as, okay, here's your sample mean. Okay, that's your sample mean. Variance looks at the spread of data around that mean. Okay, that's what that means. So, of course, the bigger the spread, the bigger the variance. Or I should say it in this way. The bigger the variance, the bigger the spread. Okay, so naturally, if the variance is kind of small, like I said, you really wouldn't see that until you compare two or more. So we could look at a number and say it's either small or big, you know, but when it's by itself, we really don't know. But if you compare it to two or other sample data sets, you know, of the same nature, then you could tell whether or not it's small or big or whatever. But that's really what you're looking at, is you're looking at the spread of data around the mean. So you could also look at it as you have a sample mean here. Here is where the line is. So you may have a data point here. Let's say x sub 1, and x sub 1 just simply means, okay, that's just the first data point. you may have an x sub 2, an x sub 3, x sub 4 may be exactly it, x sub 5 may be exactly it, maybe an x sub 6, and an x sub 7 somewhere up here, and then so on and so forth, like that. So these are the data points that fall above and below the mean. So with those deviations, we take those deviations and we square them, because here's the thing. Now, when it comes to deviations, you may have some positive or negative numbers, as you can see here. So if I looked at x2, all right, so that means that there may be like a negative or positive here. So there may be a negative number here. This may be a negative number here. This may be a positive number. That may be a positive number. So again, with the deviations, you don't want to end up with a negative variance, because variance, of course, as we know, variance is never negative. Okay? So with the deviations, we want to make sure that with these deviations, you can add them all up, and they should equate to approximately 0, if not exactly 0. That's where it should be. But in this case, variance is never negative. Why? Because of that. Well, actually, because of this. Because of that square. That's why it's never negative. So naturally, if you square a negative number, you're going to get a positive result. So that's what happens here when you have these squared values. Okay? So with your variance, it is never, ever, ever negative. Okay? That's what it is. Okay? So before we get into our calculation, I'm going to give you like a small procedure as far as calculating it. All right, so here's the procedure. And this is what one of your textbooks will say. So procedure for computing sample variance. Okay, here's that procedure. So the first, of course, would be to compute the sample mean. Okay, so that has to be the first step before you do any calculation when it comes to calculating your sample variance, be it population variance or sample variance. You cannot find any kind of variation if you don't know what the mean is. So that's always the first step. Always the first step is to calculate that sample mean. Okay, you must do that first. All right, now, second step, for each sample value, okay, which of course is denoted as x, you're going to compute the difference. All right, so compute the difference, and the difference, which is of course the deviation, we have this sample value, okay, so that is your deviation there. So again, you must know what your deviations are. So again, you may have some deviations that are negative, you may have the others that may be positive. But of course, when you add up all these deviations, you should get a summation of 0 when you add up those deviations. Okay? But with the square kind of shows where the spread is, or how the spread looks. Okay? So there you go. You must know what your deviations are. And this is after you calculate the sample mean. Remember that. All right, now, third step is to square the deviations. Okay? You're going to square the deviations. So in other words, each deviation that you get, you're going to square them. Okay, as you noticed in the formula. So in that top part, you're going to take each deviation that you found in step 2 and square those. And that pretty much leads ourselves to step 4, which means you're going to now add all of the deviations. All right, you're going to add them. So summation, like so. Okay, you're going to add up all those deviations. Then Then, last step, divide. All right, divide the sum. Not sub, but sum. All right, you're going to divide the sum that you found in step 4. All right, that you did in step 4. Divide the sum by n minus 1. Okay, and of course, as you know, lowercase n is your sample size. Whatever that sample size is, you're going to divide it. Well, you're going to subtract 1, then you're going to divide. Okay. All right. This is to obtain your sample variance. Okay, which, as you know, is this lovely guy right here. All right. So again, step 1, you cannot miss out on step 1. You must do the sample mean. Okay, before you do any calculation, do the sample mean for each sample value x. Compute the difference or the deviations. All right, which is at x minus 1. I'm sorry, x minus the mean. Excuse me, x minus the sample mean. Then with your step 3, square the deviations. Okay, x minus sample mean squared. Okay, add up all these deviations, and then divide the sum by n minus 1. Okay, and after that, you should have your sample variance. Now, to get the standard deviation, you just simply take that value, find the square root, and you're good to go. Okay, so we're going to do this by hand, and then we're going to do this in Excel real quick. Okay, so I'm going to take a small sample size. So I'm just tablet out, just give you a nice little table. All right, so these are values that we're going to use. Very small values. So we have 3, 4, 6, 5, okay, 4, and 2. Okay, so we're going to take these values. All right, so we take these values, and the mean was found to be 4. Okay, so that means you're going to add 3 to 4, all right, which is 7. 7 plus 6, which is 13. 13 plus 5, which should be 18. 18 plus 4, which should be 22. 22 plus 2 should be 24. Divide, well, the 24 by 6. There's your mean. Okay, comes out to be 4. All right, next step is you got to find your deviations. All right, this is step 2 now. Okay, so you're going to find your deviations. So again, you're taking 3 minus 4, because 4 is your mean, which gives us what? -1, right? 4 minus 4, which gives us 0. Okay, and so that means if I do the same thing going down, I'm looking at 6 minus 4, which is 2. 5 minus 4, which is 1. 4 minus 4, which is 0 again. And 2 minus 4, which is -2. Okay? So here are my deviations. So I have a deviation of -1, 0, 2, 1, 0, -2. Okay? And if you notice, again, if you add up all the deviations, I should get exactly 0. Okay? So that means, let's say if I added this to this, that's 0. This to this, that's 0. And you know the 0 is going to add to 0. So that lets you know that you have a pretty good data set. So you might want to look at it again if you do add up all your deviations and you get something well above or well below 0. That means that maybe your calculations may not have come out the way you think they should. So make sure you check on that. But in this case, it does. All right, so we're good to go. So we're going to take these deviations, okay? Take these deviations, and recall we're going to take each one and square them. All right, that was your step 3. Okay, so let's recall that. Remember, square your deviations. That's your step 3. So what is -1 squared? It should be 1. What is 0 squared? 0. So I know 2 squared is 4. 1 squared is 1. 0 squared is 0. And -2 should be 4. Okay, so that's all my deviations there. Okay, all my deviations. So step 4 now is to add them. Add up my deviations. So if I add these deviations, okay, I add these deviations, and I have 1 plus 0 plus 4, so that's 5. And then, of course, I have another 5, so I should have 10, right? So that is my 10. So for this case, again, the summation, if I add them all up, I should get 10, which I do. All right? Then the last step, divide that number by n minus 1. So I have my sample variance. Of course, top part is 10. N minus 1, so I have, what is this, 6 data points minus 1, which is 5. And as we know, well, 10 divided by 5 should be 2. So, when it's all said and done, with this particular data set, this sample data set, I should have a sample variation of 2. Now, to the untrained eye, we could look at that and say, oh, that's fairly small. That's fairly small. And it could be. And it could be. But we really wouldn't know unless we, well, compared it to another data set, whether or not it's small or not. So the 2 could be big for all we know. But again, for something like that, it could be fairly small. Could be fairly small. Because really when it comes to variances, now the variances could be any number they want to be, as long as it's positive. We don't want to have any negative variances. If we do, then something is very wrong. Okay? So just know, by hand, you can take any data set, whatever they are, compute the mean first. All right? Then calculate your deviations. That was step 2. Okay? So this is step 1. Okay? This here is step 2. This is step 3. This here is step 4. And the last step here is step 5. Those are your steps to finding the sample variance by hand. But now we're going to take the very same sample variance, and we're going to do this in Excel. All right, so I'll see you there. All right, here we go. Excel time. So I kind of set it up the same way that was written by hand. So, and I'm going to give you the reason why I'm doing it this way, because I'm actually going to show you 2 quick ways. So as you already know how you did it by hand, okay, in Excel, if you want to try this, maybe for some, they may not want to do it in certain ways. Maybe they don't want to do it, maybe they, may not want to do the actual macros in Excel. Maybe for some, it may not be as easy. So maybe they want to try it by hand in Excel, which you can. So I label it the same way with the data values of x minus the mean, and of course, here you go. So you have, I'm going to do step 1, then step 2, then step 3. Okay, so for step 1, okay, I'm just going to actually do the mean, or Excel knows it as the average. And so I'm not going to type in each number. I'm going to be lazy. I'm actually just going to highlight those cells, as you can see, from A2 to A7. So once I find the average of that, then I should be good to go have a good start. So I should get 4, which I do. So here's my mean. There's my mean of 4. Okay, there's my mean of 4 there. So now we're going to commence with step 2. So watch this. So I'm going to take the number. Okay, and here I have, what is this? What's this? 3 minus 4, because I know 4 is the mean. I can either use that cell or, type in the number. And in this case, it's easier just to type the number. And as you see, that's what my deviation was. So if you go back to the one you did by hand, when you tried it out, you should see that same deviation. So instead of me doing each one like separately, you see this little square down here at the bottom right? You see how my little plus there turns into a black cross? I'm just going to click it, hold it, drag it down, and there's my deviations that I had before. So it's a little bit of a shortcut to do each one, as opposed to naturally have to do each one separately. Okay, so we're not going to do that. Like I said, we're going to do it kind of lazy like. All right, now for step 3, I'm going to do the same thing. So what I'm going to do is I'm going to take this equal sign, as you can see, the equal sign, I'm going to click the cell, okay, because that's what deviation I have to square. Now, in order to square it, we can do hold down Shift, hit 6, then hit 2. All right, so again, you're going to hold down Shift 6. All right, hold down Shift, hit 6. That caret will appear right here. And then you just type in 2 for squared, and there you have it. Okay, and then just like you did before, take the small little square right here, click it, right click, I'm sorry, left click, excuse me, left click, hold it, drag it, there you are. Okay, after that, we're going to do the sum, which is now our step 4. Type in, so we can just simply type in sum there, Shift 9 for open paren. There you go. All right, again, just highlight that. So again, let me show you how it was done. So I just click that one cell, left click, hold it, that drags it. Or you can simply type in C2 colon C7. You could do that and it'll still be the same way. Close it out, so hold Shift, hit 0, and when you're good to go, hit enter. There's that same 10 that we had. Okay, and of course for this, well, the sample variance, we know there are six of these, right? But we know n minus 1, that's what we use. So we're just going to take this 10, which is C9, if you just want to click the cell, backslash for division, divided by 5, and there you have it. All right, so that's you doing it by hand in Excel. But let's say that you are savvy with Excel and you know that's probably a waste of time. Here's all you have to do. Find any cell in Excel, doesn't matter where. I'm going to put it right here, okay? So for this, to find the variance, okay, I'm going to simply hit the equal sign and type in var, okay? var for variance. And of course, you're going to have a lot of these. So you're going to have population, you're going to have your variant, you know, the sample variance. Now, really, you could just simply type in the var, and it should automatically give you the sample variance as opposed to the population variance. So just type in var, okay, equal sign, var, Shift and 9 to open it. We're going to highlight these cells right here, A2 to A7, okay, just like you did before. Shift 0, like so, and then once everything is there, hit your enter key, and there you have it. There's your variance, the 2. Now, if you want to go a little bit further and do your standard deviation, then this is what you type in here. So you have the equal sign again, okay, because as you know, as a matter of fact, before I go back to that, before I do that, so here you have the 2, right? And we know that to find that standard deviation is simply the square root of the variance, right? So here, really quick, if you want to do it by hand, you can take simply the square root, like so. Just type that in if you want to do that, okay? And I know we're just going to take this number of 2. You can just type it in or whatever, close it out. That's what we should get, right? Now, let's say if you wanted to bypass the variance and just go straight to standard deviation, here's what you're going to type in. Again, equal sign. And for standard deviation, you're going to type in STDEV. And you see it gives you your different choices here. Again, the population and the sample. So if you type it in just like this, you're going to automatically get this, the sample. You're going to automatically get that. So I have my standard deviation, equal sign, STDEV. Again, Shift 9 to open it. I'm going to highlight the cells again, close it out. I should get my 1.414 if I hit the enter, and that I do. And there you go. That's how you can do sample variance and sample standard deviation in Excel. Now, really quick, I'm going to go back to the explanation of n minus 1. So here is the simple, or hopefully simple, explanation of this. So when it comes to computing the sample variance, we use the sample mean to compute the deviations, as you know. For the population variance, we use the population mean for the deviations, the data point minus lowercase mu, which is of course the population mean. Now it turns out that the deviations using the sample mean tend to be a bit smaller than the deviations using the population mean. If we were to divide by n when computing a sample variance, the value would tend to be a bit smaller than the population variance, which is basically what it should be. So when you're dealing with your sample variance, again, it's a estimator. It's an unbiased estimator of the population, just like the sample mean is the unbiased estimator to the population mean. That's what they are. These are basically your statistic. Your statistic should make some inferences about the parameters. The parameter would be your population mean, population variance, as well as your population standard deviation. That's what they are. So in this case, when you have your sample variances, they kind of make inferences about the population variance. Okay, so your population variance may be slightly bigger than the sample variance, which it should be. All right, so here we go. All right, so it can be shown mathematically that the appropriate correction is to divide the sum of the squared deviations by n minus 1 rather than n. Okay, the quantity n minus 1 is sometimes called the degrees of freedom for the sample standard deviation. The reason is that the deviations x minus x bar will always sum to 0, which I said before. Thus, if we know the first n minus 1 deviations, we can compute the ninth or the nth one, the nth one. Okay, so that's what that means there. I'll give a more standard, a bigger explanation of what that means. All right, so again, when it comes to the degrees of freedom, all right, so degrees of freedom and sample size, the number of degrees of freedom for the sample variance is 1 less than the sample size. That's what that is. So in other words, like all the other ones, like in this case, like let's say n minus 1 values can be anything they want. The nth one has to be what it is when all of the other ones have already been calculated. That's basically what it's trying to say. Hopefully that kind of clarified it. I may have made it a little bit more confusing, but you'll see it more and more as you practice with it. All right, but that is your sample standard deviation, sample variance, as well as population variance. These numbers are used in comparisons of if you have data sets, again, with your means being similar to each other, and there's really not much difference. The variance can pretty much show you the differences in the spread of data. That's what the variance is for. Also, in translation, the variances and your standard deviations, which become a little bit more prominent, is you can use these when it comes to your z-scores. That I will save for another video. Okay, but in the meantime, practice, 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 study, study, study. Hopefully this helped out tremendously. If you have any questions or if you want to comment, you know what to do. Comment below, good, bad, or indifferent. I take them all. All right, so hopefully this helped out. Again, population variance, sample variance, both by hand as well as in Excel. All right, practice and enjoy.